everyone. We are looking at Lesson 8-3. This is the second part of solving systems of equations by graphing. So if the solution to a system of equations on a graph is the point of intersection, then brainstorm and answer the following. Okay, would it be possible to have a system of equations with no solution? Well, you might want to think that if they never intersect, they would not have a solution because the intersection is our one solution. So, yeah, as long as the system does not intersect. Okay, on the other side of that, is it possible to have infinitely many solutions, meaning that you could never count the number of solutions? That would also be a yes, as long as the system intersects in many places. And that's what today is going to be about. Those that intersect, those that doesn't. That was Penny. Oh, she's messed me up there. Intersects in many places. And we'll talk about what that looks like. Okay, so the first one, this is what we were doing last week and yesterday. So we were looking at two graphs that intersect at one point. That one point was an XY coordinate, and it had one answer or one solution. We could plug that XY coordinate into both of those equations and it would be true. What you knew about those is that they had different slopes. Okay. Then we have, today we're going to look at these two situations here. We've got these parallel lines on this middle one. These parallel lines will never, ever intersect, so that means that there is no solution to these. Okay, there will never be an X and Y coordinate where they meet. The way that this happens is that they have the same slope, but they cross the y-axis at different places, so they have different y-intercepts. Okay, so this graphic right here, they both have the same slope, but this one crosses the y-axis at a negative intercept. This one crosses the y-axis at a positive intercept. Okay. And then the last one we have here, you can tell that this line looks a little bit thicker than the other ones in the other two graphs. That's because what we have is we basically have two lines sitting on top of each other. Okay, so this is what we call infinitely many solutions. Okay, so someone in second or third period said, do you mean that they would basically be the same equation? Yeah, but they're not going to look like it on the outside. Okay, so they have the same slope, just like the parallel lines do, but they also have the same y-intercept. Okay, so when they're both placed in slope-intercept form, they have the same equation. So let's take a look and see what these two situations look like. Okay, so remember, we know that if it's in slope-intercept form, it shouldn't take us very long to graph. We're going to start with the b, okay, and then we'll apply the slope, which is the coefficient of x. Okay, so pause if you don't have a ruler, grab a ruler or some kind of straight edge, and let's go ahead and start graphing this first one. I do want to go ahead and label the x and the y axis. All right, so I know that with the first equation over here, it is in slope-intercept form, so I'm going to go to the y-axis and plot -3. And my slope is 2. Remember, I need that as a fraction, so 2 over 1. So I'll go up 2 over 1, up 2 over 1. You don't have to create the stair steps. I just wanted to make sure you know where I'm getting the up 2 over 1 from. Okay, and 2 over 1. And I'm going to go back to the starting point down here at this -3. And instead of going up 2 over 1, I'm going to go down 2 and to the left 1. Okay. And I have this pretty steep positive sloping line going through all those points right there. Now, the second one I have is not in slope-intercept form. You learned those 2 steps last week, or you reviewed those 2 steps last week. If you don't have them, I'm going to put them down here. The first step is to move the x term by adding or subtracting. You have to do the opposite of what's there. Okay, and when I say move it, we're going to move it to the right side of the equal sign. The second thing you're going to do is multiply or divide by the coefficient of y. Okay, so you're doing the opposite of what's there, or the inverse operation. So looking at this second equation here, it's not in slope-intercept form. That first step down at there, maybe I should zoom out a little bit, is to move the x term by adding or subtracting. So I'm going to add 4x. I'm going to do the opposite of what's there on each side of the equal sign. Okay. I am not adding that 2 plus 4x over there. Okay, those are not like terms. I cannot add them together. We know that y equals mx plus b, so my mx term needs to go first. So I'll put 4x, 2 is positive, so I'm going to bring down that 2 and make that a positive 2. My second step down at the bottom of our page says multiply or divide by the coefficient of y. Well, the coefficient of y is 2. We are multiplying, so the opposite, or the inverse operation, is to divide. So what I do on one side, I do on the other. So 2y divided by 2 is 1y, or just y. 4x divided by 2, and 2 divided by 2 is 1. So that equation looks very similar to this one up here. They have the same slope, but they cross the y-axis from different places. Let me go ahead and change this color. Okay, I'm going to put positive 1 right here, and my slope, again, is up 2 over 1. Up 2 to the right 1. Down 2 to the left 1. And you can see that these 2 lines that I'm creating are never going to intersect each other. They are parallel. Okay, try as good as I can to draw my parallel lines. There we go. Okay, so this is a no solution. They will never cross. Okay, let's take a look at number 2, and we're going to keep those rules down there in mind. Okay, I'm going to label my axes again. All right, so the first one's pretty easy. It's already in slope-intercept form. I'm going to start at a positive 4 on the y-axis. My slope is -1 over 2. Remember, just move that negative sign up to the top. So my slope is a -1 over 2. That's my rise and my run. So I'll drop 1, but I'm still going to run to the right 2. Drop 1, still run to the right 2. Okay. Go the opposite direction, so I'm going to go up 1, over here, up 1. Okay. So I'll draw my line, and I've got a negative sloping line. Okay. My next one is in standard form, so I got to get it to that slope-intercept form. There's not a number in front of x, so I'm going to put a 1 there. Let me get that x out of the way so we don't get confused. Okay, so my first step is to move the x term to the other side of the equation. So I'm going to subtract 1x on each side. Okay, bring down the 2y. Remember, my x term is first, so bring over the -1x and add 8. Okay. Next step is to multiply or divide by the coefficient of y. So I'm going to divide everything by 2. That leaves me with y. And look what I'm going to do here. I'm going to leave the negative 1 over 2 in fraction form instead of changing it to a decimal, because remember, I need rise over run. And 8 divided by 2 is 4. So there I go. Notice anything? Hopefully what you noticed is that this equation right here is the exact same as this equation up here. So when I start plotting my points at -4, positive 4, drop down 1 over 2, all these points, including the segments in between, are solutions. So because that line goes on forever and ever in both directions, we have an infinite number of solutions. So we have infinitely many solutions. Because I'm lazy, I don't write it out. All right. Now, let's take a look at the back side. And I'm going to come back to number 3 because we're going to put a lot of lines in there. In fact, we're going to put all 6 of these equations over here. And before we do that, my brain doesn't work very well with that, all those lines. So I want to look at number 4 and 5 first. Okay, so number 4, Ava thinks that line A and line B would have no solution because the lines do not intersect on the graph. Is she correct? So she's right in the fact that those lines do not intersect on the graph. But what would happen if the graph kept going? Or you could see where the lines kept going. So line B, go out that direction. Line A would go out that direction. Eventually they'd cross way out in space, so to speak. So Ava is not correct. The lines would eventually intersect off the graph. And you can tell that they don't have the same slope, and if they don't have the same slope, they will intersect. Number 5 says write an equation that would have infinitely many solutions with the equation below. So that means, like we said earlier, that they would be the same equation. Okay, so let's put that equation down here, this 5x plus 3y, let's put it in slope-intercept form. So if you have to flip over to the front of your page, you can. We need to move the x term to the right side of the equal sign. So I'm going to do the opposite of what's there, and I'm going to subtract it. And again, I'm putting that 5x over to the side because I don't want you to tell me the answer is 7x over there. They are not like terms. You cannot combine them. And that's your x term, so that's going to go first. And we're going to divide everything by 3. Okay, and 3y divided by 3 is 1y. Now, -5 divided by 3 is not a pretty number. And it's very ugly repeating decimals. So we're going to leave it as -5 over 3x. But 12 divided by 3 is a pretty number, so there we go. So this is an equation that would have infinitely many solutions with that equation right there. Now let's go back to number 3 and do some of these equations. So I'm going to get rid of this here so you can see it on my end. The first thing that I had my students do was I had them graph all the ones that were in slope-intercept form. And that is this one, and this one. I walked around to make sure that they knew what they were doing. So pretend that I'm over your shoulder. If you do not know at this point in time how to graph, if something's given to you in slope-intercept form, you need to seek out either Miss Bird or myself and get some help. You've got to be able to do that. So the first one that we have highlighted, we are going to start at 7. Our slope is -1 over 3, so we're going to go down 1 unit, to the right 3 units. Okay, and continue to go down 1 to the right. Okay, and you can see, or at least I hope you can see, that it is running parallel to line A. Okay, and I guess I should have gone over the instructions a little better than I did. It says complete the table by identifying the graph line that would have no solution, which means parallel lines, with each given equation in the table. Okay, so let's take a look at the next one. I'm going to change color. Y equals negative 2/3 x. Remember, if there's not a b over there, that means the b is 0, or the origin. So we'll start at 0, and our slope is negative 2/3, so we'll go down 2 units, but we're still running to the right 3, down 2/3. Okay, I'm going to go back to the middle and go the opposite way, so I'm going to go up 2/1, 2, 3. Okay, so I can get a good idea of what this line looks like. All right, and that one has no solution with line B. Okay, and then the last one that's in slope-intercept form, we have y equals 2x minus 1. So we're going to start at -1. And our slope is 2, or 2/1, so I'm going to go up 2 to the right 1, up 2 to the right 1, and I can see very quickly that it's line C that I'm running parallel to. Okay. I'm going to try to find some room to write these equations in slope-intercept form for us. Okay, so now I'm going to look at this one right here. I'm going to write it up here. I've got 2x plus 3y is equal to a -12. First thing that we do is we get rid of the x by doing the opposite of what's there. Gives me 3y is equal to -2x minus 12. Divide by 3. And that's going to leave me with y equals -2/3x minus 4. So I'll go down to -4, go down 2 units over 3, go down 2 units over 3, and I'm going to go back to my starting point, go up 2 units, the opposite direction, 3. You can see that it's very close to line B. Okay, that's our line that is parallel to. Okay, let's look at the one in the middle. We have, sorry about that, -3x plus 4y is equal to -8. So we're going to add 3x to each one. And I've got 4y is equal to 3x minus 8. We'll divide everything by the coefficient of y. And that's going to leave me with y equals 3/4 x minus 2. So I'm going to go down and start. See, this is why I wanted to look at the bottom ones without all these lines over it. So -2 is right here. We'll go up 3 and to the right 4. Okay, so make sure I did that right. Go up 3/4. Up 3. Trying to see what line I'm parallel with. 1, 2, 3. And I may have made a mistake. Okay, so let me double check what I've got. Oh yeah, how about that? I wrote the whole equation down wrong. That was a -8x. Sorry you have to deal with this. Alright, so let me correct that. Get rid of those points. Put my purple line back. Thank you for being patient. to add 8x on each side, not 3x. Bring down my 4y, 8x minus 8, divide everything by 4, and I'll have y equals 2x minus 2. Much better. So I still start at -2, but this time I'm going to go up 2 over 1, and it looks like it's going to be very close to that red line. Up 2 over 1. Yeah. Much, much, much better. So my line here is almost on the same line, but not quite. So that's going to be line C again. And one last one, and let's hope I can do that one without any mistakes. Okay, our last equation is 1x plus 3y is equal to 6. We'll subtract 1x on each side, and I'm left with 3y is equal to -1x plus 6, divide by 3. Y is equal to -1 over 3x plus 2. All right, we'll go up to 2, drop down 1, to the right 3, down 1, to the right 3, and this time I'm going to go up 1, I'm going to go back up to the left 3, 1, 2, 3, okay, and I can see that even though it's intersecting the green line, it is parallel to line A. Ooh, that was tough, guys. Sorry about that. Too many lines there. All right, I hope that helps. And if you have any questions, see either me